So, all right, go ahead. Okay, got 20 minutes.
All right,
All right.
a lot of choice would have to go into trying to figure out what you want. So right now you're using lead acid batteries. And by the way, I did some research on that regeneration. I never heard about it until you told me about regenerating lead acid batteries.
There's nothing online.
Yeah. Oh, I found one thing online. I sent it to Ryan last night about regenerating lead acid batteries with electric pulses. I never heard about that until you told me about it. But it sounds pretty interesting. So lead acid batteries.
The revitalization. Well, those machines are sold in the stores over here.
Mm-hmm.
Yeah, you can just go to one of those car appliance stores and get one. They are not even that expensive.
Yeah, mine was just in lithium batteries. That's all. I mean, I was graphene lithium batteries with non-flammable electrolytes. But you're looking for storage, right? And speed. So with the weight you would have with those lead acid batteries, you can probably use something like Michael has. It's non-flammable, which is really beneficial, and it's very fast. But you'd have to marry the technology together, and work on BMS systems and everything else for it. So because
absolutely.
Be a different battery management system, but your weight ratio and your space would be less, because if you're having to put hundreds of lead acid batteries, that's a lot of space. Then you have the off-gassing of lead acid batteries, where if you had a hybrid supercapacitor like Michael has, where maybe you have some of the best of both worlds. So a lithium battery has great energy density, but it doesn't have the speed of a supercapacitor. So a supercapacitor will charge and discharge in milliseconds, right? Where a traditional battery, even if you have a power cell, takes time to charge, takes time to discharge, and they have great storage. But if you're marrying the two of them, and with the weight you're using, your energy density basically is the weight, you should be able to pack a lot more energy density in the same space. We'd have to look at, since you have a 25-year warranty, I believe, or is it 30-year?
On the generator?
Yeah.
No, it's a 10-year warranty, but that's what I tried to explain yesterday, that we need to test and see which is the most weak component. Like, for example, a LED light, we always know that it's the transformer that breaks the ballast in the light. It's not the chip or not the cables. So if we know exactly, can identify which one is the one that we break, then we'll put into a service system under the warranty program, and then they will just be swapped out at certain points of time.
So your battery pack would be swapped out at a certain time, because that'd be your
No, not battery, the parts of the generator.
Okay. How long are you warranting your battery packs for? Is that separate from the generator itself?
We don't manufacture batteries, so the warranty is as long as the battery manufacturers say. What are those, usually 5 years?
Okay, so it's not a complete system then?
No, we only manufacture we will be manufacturing the generator and the inverter to go with it.
The generator and the inverter to go with it down to your battery pack.
So all the other components will be bought from other suppliers.
Okay, and it'll pretty much marry with any other thing. Okay, that was one of the things I was.
You can use any kind of battery. Lithium is of course way better, but then you have the fire risk, of course. So I've chosen to use only lead acid batteries in these systems, and that was my own call, because, well, we all know what happens when a lithium battery gets overcharged. You can't even put the damn thing out; it will just keep burning.
No, I mean, that's why Michael's battery is appealing. Maybe Michael's doesn't work, Nanotech's batteries would be appealing because they have a non-flammable battery also.
Yeah.
But Michael's would have less resistance. If everything checks out with it, would be really good for you.
So how much do you have any idea of the price to that one? How much would a kilowatt be of this technology, the hybrid version?
That would be Michael. He hasn't given me any prices yet. We'd have to. He's on the next call, I believe.
Okay.
That might be a separate call on it. But if you guys need a prototype design for your BMS to interact with it, so like if you're doing household or if you're doing container, there is a company I know that will design, manufacture, and they'll do the BMS systems for these, and they'll do the light manufacturing until you guys are up to speed. So
that's excellent.
yeah, so I have some guys I can work with on that, but we just have to figure out all the requirements of the battery packs.
Well, see, that's what we need to start testing, and I assume that most of this information would come from the Koreans. Of course, they haven't given us the blueprints to the thing itself, so we know how much current actually runs through the different models. The very smallest one is one kilowatt. Is for your camper or your cabin or something like that. It just gives enough to charge computers, a little bit of lights, maybe small television, and so on. And then the largest ones would be in the gigawatt scale. So there are a lot of different models. It would be some design work and some testing, R&D that has to be made around this. Then we need to calculate, of course, because lead acid batteries, they are dirt cheap. Well, they have become a lot more expensive now, of course, but it's the cheapest battery around anyway. So we need to calculate if the other battery that you're talking about, if it becomes so expensive that the LCOE will change drastically and get more expensive, or does it actually start producing so much energy that we can even go down in pricing? That's of course the desired outcome of what we need to do.
But resistance is your biggest killer, right, in your product, from what I understood yesterday?
Well, as the extra generation happens in the battery pack, the generator keeps driving the electrons inside the battery pack, and that's how the static current occurs, and that's where it's captured. So with less resistance, the electron flow should be much freer. I don't know which use would be appropriate to use for that. But the more flow we can have of electrons, then the theory is that we could actually 10x the already 10x. So meaning withdrawing a watt from a panel could be made into 100 watts.
A question for you. Has anybody taken this unit? I mean, because this is like groundbreaking. Has anybody taken this unit, just hooked up the battery pack, disconnected all external sources, okay, and just put the battery pack and the generator together and just watched it run? Was that part of the test? You guys did that?
Yeah, we did that.
Okay.
Yeah.
I was just kind of curious because it's so revolutionary that most people are going to really balk unless you can prove it out.
This is why we need to stop talking about the 10x. Nobody needs to know what it is, but of course now when we're talking to investors and partners, they need to understand what the system is, how it's working. But once we start taking it to the market and actually installing it at clients' places, we're not going to talk about how we generate energy. We just install a system. If they need 1 million kilowatt peak, that's the system they're going to get.
Okay.
But we need to stop talking about the fact that it's disruptive as it is, because first of all, many people don't understand it. They refuse to understand it. They only understand what they know, which is conventional solar. Then they understand that, okay, if you add batteries to conventional solar system and oversize it, you can have a little bit of extra energy throughout the night. But that system would become very expensive if you want to cover your house with energy 24/7. You would have to have a ginormous battery pack where you store the energy that you capture daytime. And if you have a bad day and it's just raining, you wouldn't reach that amount. So you would have to oversize it so much. Mm-hmm. And this is why the generator is so special, because it keeps self-generating, even if it if we would have days where there's no sun for a week in a row, this machine will just keep on producing energy at all times.
Pretty groundbreaking.
Yeah.
So my buddy, well, actually one of my partners in what I do is Rob. Ryan's talked to him. He's the guy that invented the supercapacitor cap for Maxwell, also the dry process for Tesla. He's on my team that we can bring him on for battery advice. He knows more about supercaps and other batteries than I'll ever forget about. He's probably forgotten more than I know. So he's been in the battery industry as long as I've been in manufacturing. he was like the second guy at Maxwell. You know, Tesla bought out Maxwell and stuff like that. He would be a guy that we can draw on and bring him into the conversations. Sorry, my dog's barking. Another dog. Let me shut my door.
Yep.
Our two dogs sit there and argue across the fence.
Yeah, well,
yeah.
My wife is fighting with our dog to cut her hairs. It's getting long and it's getting warmer out. So yeah, she is.
We have mutual problems. My wife was just fighting with my dogs.
Yeah.
Anyways,
all right.
He's a guy we can bring on if you guys like to. You know, he can either run under the NDA I signed, or he'll be more than happy to sign the other. But he'd be a good guy to have on the battery pack part of it, the portion of it.
See, the thing is that we just need to put together a sufficient enough team, and the guys at the factory, they are very, very brilliant people. So they will, of course, be a part of the team. Unfortunate thing with those guys, they only speak Korean, and the one guy that speaks English, he speaks very poor English. But well, I have understood how to communicate with these gentlemen. So we would just have to choose a place where we would do all of this R&D, because if those two systems mix as we think they will do, we know that they will do, the graphene will do something. It will raise the efficiency of the generator because we will remove the resistance. But by how much, that's something we need to see. And the battery management people needs to be there. Even if it's a hybrid graphene battery that cannot catch fire, we should not overcharge it anyway, because we would just kill it very fast. So anybody that you think should be a part of this team, and then we could start to get some kind of budget, because next thing we need to do, once we have found the compatibility between these two products, then we need to haul ass on IPR-ing that combination. So nobody else in the world, even if somebody else would come up with a generator and some other graphene battery innovator, I think we still have a window of five years or more before somebody would come up with this. But we need to make sure that IPR is done immediately.
Does this have?
So we need a couple of engineers in there as well that can follow this work and write up the IPR. So we need to create some kind of budget that we can present to the investors. But this is a cost that we need to take. Whatever it costs, it doesn't matter. That money will come back very fast if this, I think. We know it will to some extent, but how much, that remains to be seen.
Are you looking for factory design budgets? What are you looking for? All of the above? How much it costs to make a battery?
Well, how expensive are you, and how expensive is this other guy? Because this will be a full-time job. We need to.
All right, so I'll give you an idea. Okay, normally I usually make about $250 an hour. Okay, but in nanotech, I took a ton of stock. Okay, I walked out with 321,000 options over 8 years, which is a sizable portion for what I did for the company. So both Rob and I are sitting in a pretty good position. Okay, there's another guy I can bring on too that can look at, TQMS, all the other quality management systems that you're going to have the manufacturer, the ISO process, everything else, and all those budgets can be put in for what you need for, good lean manufacturing. The design of the plant, I have another company that I work with. They're a separate company from mine, but they've been very instrumental on the engineering side of the battery manufacturing companies, the layouts, everything else, where they, put it in a CAD drawing and everything else. Nothing's cheap. Okay. These guys are, the top of the game type people. I can ask each one of them, what we can do. We can formulate a budget to do that for you guys. No problem whatsoever. Okay. But yeah. The nice thing about Rob, he still quasi works for Nanotech on the Chico scale up. He's on advisor. He's not traveling out to Chico anymore. Blair, I believe, is a free agent right now. He's the guy that set up all the ISOs, all the TQMS. Why can't I think of the word? The machine that talks to, it'll come to me. But anyways, all the systems to go all the way to the ERP system for total quality management. So your machines are coming out perfect every time. and setting up the line. Automation is something we've done a lot of, where maybe you want automated. I haven't seen the process, so we'd have to go to Korea, look at the process, design it. You said you had a better way of making it.
Yes.
We'd have to investigate that and really kind of get an overall scope. Then we could formulate a budget. So we'd have to
I'm now I'm talking about the testing the battery with the generator. We already have the factory flow. We know how the factory is going to be built. We have very brilliant component engineer over here. So, but of course, I trust your expertise. So it wouldn't hurt to have a couple of more pair of eyes on the factory flow setup as well, because our engineer, he's well, we have two engineers, one component engineer, and we have our other brainiac who's well, he has 4 different engineering titles, and he's a DNV lead auditor. So for the certification process, he's definitely going to be our #1 guy with that. But he would need help, of course. So yeah, I probably need to sit and
Michael also.
What we...
Sorry, you're breaking up there a little bit.
No, go ahead.
Michael may have some ready-made solutions. I know he has some Chinese manufacturers that might have ready-made solutions with a BMS. It may not be optimal, but it might be enough to get you by until you can design your total system.
Yeah, sure. We can have a look at that as well. Yeah, definitely.
Is that correct?
Yeah, well, there's a lot of work to do around this.
Mm-hmm. Is that correct, Ryan? Michael may have his own systems with small BMSs.
Yeah. Well, you can ask him. He's right here.
Oh, okay, cool.
Morning, Mike. The man, the myth, the legend here. Great.
Yeah.
Let's see here. So, gosh, we're gonna have to shift gears a little bit here. Scott, we'll get into this. Mike, this is going to be an absolute phenomenal call. So, thank you for joining us. I want to introduce you to some very key individuals here. Prajesh here, first of all, who you met that came to your lab. Prajesh, you can go ahead and unmute if you like. Prajesh is bringing on some really big people today with us from the Saudi Arabia project. That line project is absolutely just bonkers right there. And obviously, they're looking for battery technologies and energy solutions. And then we have Scott Lane on here as well from Nanotech Energy Setup, Mike, also here as well, who's helping look at the proposition of your technologies and the battery technology, working with Peter Coach here, who's in the middle here. Peter Coach represents the Energy Amplifier technology. That this technology is pretty mind-blowing. I know that Tim originally gave you some information about this, Mike, but Peter is the head of distribution. He had the studies done in Finland at the University of Finland, or whatever it is. Maybe you've seen those attached documents. But Peter, why don't you go ahead and say hello and introduce yourself, first of all, and explain how this technology really could be massive with the graphene batteries, what's possible, and then we'll get into the Saudi Arabia discussion. Mike?
Yeah, absolutely. So the technology that we discovered is an energy amplifier. It can actually amplify the amount of electrons in a system. So whatever we capture with the solar panel can be amplified 10 times. Then it's a very simple system. It doesn't create heat. So we have studied it for 3 years now, and it's not a question about it. The workability, it actually works way better than we have announced. So we have a theory with some very brilliant people from the factory, and of course our team here in Finland. When connecting this one to a graphene battery, we can further expand the
You're cutting out. It's very important that Mike hears you say this, Peter. 1 second. You got bad reception there.
All the way up to 10 times.
Wait, Peter, please repeat that, Peter.
We already did it 10 times.
Peter.
Hi.
Peter, I need you to have better reception.
You're not hearing me?
We can hear you now.
I shouldn't have that because I'm right next to the Wi-Fi.
Okay, go ahead and say that again.
I'm right next to the Wi-Fi.
Very important to explain the importance of what the battery can do, the graphene battery with this. Please repeat.
Yes, so we think that the 10x that we can extract from the generator system when connected to a graphene battery, we think that that already amplified amount of energy can be further amplified another 10 times. So in practice, that would mean if we extract 1 watt from a solar panel or any other seed energy source, we can amplify it 10 times, but instead of using the lead acid batteries as the system uses now, with graphene, that 10 times could be another 10 times. So the 1 watt we extract could be made into 100 watts.
You hear that, Mike?
Good morning.
Yep.
Wow.
Okay. So, Peter, say hello and introduce yourself to Mike. You can say hello.
Okay. Mike, where we have Mike?
Mike Dana, M Dana right there, blue shirt.
Okay. So hi, Mike. I'm Peter from Finland. I've been working with this project now a little bit over 3 years, and we are now about to start production, large-scale production. The current factory is very, very small. Everything happens by hand. It's very congested. So what we have done now, we have come up with a way on how to do this with automation, where we can ramp up the production quite aggressively from the small amounts that they're doing currently. And every factory unit would be about 200 megawatts of capacity. So if you want me to talk a little bit about the capacity of the system, I can do that as well.
I have no idea what you're doing.
Okay, we have an energy amplifier. So a regular solar system of 1 megawatt can produce about 960,000 kilowatt hours per year. But our system, 1 megawatt, will produce 7,300,000 kilowatt hours per year. So that's a huge difference.
Explain how this works with resonance, Peter, a little bit about the science behind it.
So the system is very simple. It's just a little bit of chipboards, and then we have a large condenser. Inside the condenser, we drive the electrons in different speeds with resonance amplification. So when the electrons in the system, they pass each other in different speeds from 400 hertz to 800 hertz, we have static current that occurs every nanosecond.
Well, excuse me. What's the voltage?
The voltage?
Yeah.
Now you have to. You mean inside the system?
Yeah, you're bringing in power at what voltage?
That would depend on the panel. Hold on a little bit.
Good morning, Mayor.
Good morning. How are you doing there?
Great. It's nice to see you again.
I know. It's early wake up for you anyway. What time is that?
8 o'clock Seattle time here.
Okay, that's not bad. That's not bad. I thought it would be about 6 p.m. in the morning or something, right?
I wake
It's
up early.
220 volts in the system.
DC? That's DC?
Yes, DC, yes.
Okay. Go ahead. I'm sorry. I need to know some of this stuff.
Okay. What was the specific reason? Why did you want to know that?
What's the current that you're bringing? What's the amount of current you're bringing in?
The current, whatever the panel gives out.
You're talking about the solar panels?
Yes.
Okay.
Okay. Go ahead, Peter.
Was there any more questions to that?
Keep going. I'm sorry to interrupt you. I just need to trying to figure out what you're doing.
Okay. Yeah, many have tried that, and yeah, I only have 3 people in the world so far that has been able to tell me what's happening inside the system, that figured it out very quickly.
That's good. That's good. That means you got a secret.
Yeah. Otherwise, we wouldn't be on this call. Everybody would have it already.
Explain, Peter, how it's like kind of Tesla tech, the stays that you've had at Finland, the government's involved in this, or whatever else you want to share there.
The government?
Well, you're working with.
No, we are staying out of all government-related business. They are not welcome.
That's dangerous, very dangerous for him.
I like you already.
Yeah, it may be so, but you know what the government will do with something like this?
Yeah, they'll screw up a wet dream.
They will do nothing. And we are doing this to actually change things in the world, because there's a lot of people living without electricity, and this is why we came up with a system how we can bring energy to cost price to people, and do it efficiently and more safely. And they want a green transition, and this is the product to do the green transition with, because we have no emissions in the system when it's operational.
Mike, you want to share a little bit about your battery technology, how it's different?
Well, let me give you a little demonstration. Maybe this might help them a little bit. I hope I can see it so that.
Yep. I'm turning it to. Oh, there you go. See here.
You see it?
Yes, Mike.
Yes.
Yeah, our Graphene Battery is 12 volts. Yeah, it's dead. It's completely dead. It's at 0%.
Yep.
So we turn the charger on. And oh, let me set the charger. Working backwards here. Sorry.
Dyslexic.
Yeah, that happens. You're upside down.
Oh, the screen level.
God damn it.
We believe in you, Mike.
That's what I'm doing. The computer.
You're not on mute, are you, Mike? Good. Okay.
It's ours. About 3 seconds to charge it once I turn it on. You see it here?
Yeah.
It's 100%.
Yep.
So I think we can fit in very nicely with what you're doing. Our our unit as a standalone, you're talking about amplification. So we can take 1 megawatt worth of solar and we can charge 5 megawatt hours worth of our supercapacitors. As you know, a lithium battery is going to take hours to charge. Ours will take it in charge in 1 hour. So you can get probably 4 turns during the same amount of time as you can with lithium. If you add that with what you're doing on your amplification, you got the holy grail.
Wow.
You see, this is what I'm talking about. So here's my response. I said it maybe 10 times 10, but you're already doing 5. So now it's confirmed. We can, from a 1 megawatt system, we can do it 10 times more times the 5. This is the solution. I've seen it now. Yeah. Wow. I'm not going to sleep tonight. God damn it. Sorry, pardon my French. Yeah, for 3 years I've been fighting with this, and I was involved with a group from Sweden that already had their product almost made. But then unfortunately the main guy, he passed away. He got cancer. It was very abrupt.
When he passed,
so the project stopped. And these guys were really into the graphene. They are even members of the National Graphene Institute in Manchester. So and they had a huge project with Duke Energy that were already bagged and closed.
One of the characteristics of our unit, so that everybody's got a good warm fuzzy, is that we contain no chemicals. There's no chemicals in our unit whatsoever, so it cannot catch fire. That's the most important thing, is it's got safety aspect. When our unit was designed, I had 3 goals. The first goal was safety. You don't want to have something is going to be sitting there like a lithium cobalt bomb. The second box I wanted to check was, if someone's going to spend good money for a unit, we want it to last a long time. And as you're aware, a top tier lithium battery, Tesla, LG, Sony, Panasonic, you're going to get probably 7,000 DODs if you take care of it. We warranty ours for 25,000, and the only reason I picked 25,000 is no one's going to believe $1 million. I mean, you put the battery in, you're never going to wear it out. And
have you stress tested it?
Yes, sir.
Did you try how many times it will last for?
Yes, sir. How about 1,250,000?
Oh my God!
Okay, and that's a certified number.
Gentlemen, I sorry to interrupt you, but just to understand what he's talking about here, if it was 100,000, if you charge it once a day, that battery will last for 370 years. We are now talking about 3,700 years if you charge it once a day.
Wow.
And again, here's the thing that nobody wants to talk about. End of life. Okay, well, this is going to end a lot later than all of us combined put together. But when it finally does, you can pull this thing and put it in your garden. There's no chemicals in this thing.
No, because it's carbon.
Ship this off to some third world country to get rid of it. So I think that what you have and what we're doing is a perfect fit. The only missing ingredient here is the funding. If there's funding available.
That's where Moyer comes in, but we'll get to that in a second.
We'll get to that, yeah.
We'll introduce Moyer in a second, but Scott Lane, just one technical question. We got 2 great technical people. Al here that works with certifications, been studying Mike's batteries. Just a heads up. Al, got Mike and him are working together, and Scott Lane. Al, Scott, could you ask the one question about the just on the chemical side real quick?
It contains no electrolytes, right?
No, sir.
So it's just a solid state battery?
100%.
100%. Okay, that's my main thing. It's has no electrolytes, solid state. Usually solid state has either gel electrolyte, a solid electrolyte, has some type of things to transmit it. Nothing.
No.
Okay.
No, you're gonna you got a lot of universities, you got Stanford, MIT, so on and so forth. They're living off of grant money. Okay. They feed off of grant money. So, they're playing with watch size batteries and all this kind of crap. Well, they haven't progressed in the last 10 years because they're fat, dumb, and happy. Our unit's a mature unit. It's in production. In fact, this unit right here, You see that? This unit right here?
Yes.
I made that for Boeing. Boeing 737s and 787s. They have three NiCad batteries in their planes, and they came up. Somebody came up with the bright idea to try a lithium battery. And you remember about 2 months ago when they had grounded, they had shut down all the airports, and they said they came up with some cockamamie excuse. Well, the real reason of that is that the battery started to smoke when it hit altitude, and they grounded the whole fleet. So about a month ago, I had about six of their engineers here in my little shop, and they asked me if I could build a battery that wouldn't explode. And this is the end result. They're coming to pick it up tomorrow. So we do production, but we do prototypes as well. So whatever you're going to need to make your project a success, we can do.
We have another very interesting aspect to this when you're talking about the airplanes. You gentlemen are probably familiar with that by 2030, these large container ships will not be able to operate on diesel or gas power in ports anymore. So how are they going to get those ships in and out? They need to have electric propulsion. And there's no other battery in combination with the generator that can go into a ship, because I don't think you would like to put lithium batteries in a ship, and if it catches fire, that ship will go to the bottom in that port. So this is a perfect combination. Once we can get these two products together, that's the green transition solution right there.
Peter, just a heads up also, Albert here. Albert, if you'd unmute and just, you've tested the previous battery. It sounds like Mike has version 4 coming out, correct, Mike? That Albert has not tested? I never seen you smile.
Why I got to be careful what I tell you, because
I know.
you're like a robot. You tell people shit.
Yeah. He's talking too much.
Version 3, which we're on currently, everybody wants to know density. Everybody's like, they're in that mindset of lithium, and you're looking at about 260, 270 weight to kilograms. And so are we. We're there. We've been there. Version 4, which will be out pretty much in about 2 weeks, is about 460 weight to kilogram. So the unit's going to become smaller for the same amount of power, or in the same exact enclosure, it's going to be twice as powerful. That's pretty much it.
Wow.
Can I ask you something about that? That's very important, because the current system that we have, let's just stick to the megawatt so everybody understands it very, very simply. For 1 megawatt, we would use about 500 watts of panels, but we would use 2 megawatt of batteries. So how much would a kilowatt equivalent, what would this battery of yours cost to the kilowatt?
We usually go 1 megawatt worth of solar to 5 megawatt hours worth of battery.
Yeah, I understand that, but let's take it down to just the kilowatt. Do you measure it in the size of the unit, or is it per?
The unit is measured in megawatt hours. We can put for storage only 4 megawatt hours in a 40-foot container.
Yeah, but you surely have smaller batteries as well.
Oh yeah, we got here. This is a smaller battery. We got our residential units are at 48 volts. If you're at
48 volts, now I understand why you asked the voltage. Yeah, I get it now.
If you're at 200 volts, we take our standard unit and we run them in series and parallel to bring it up to 250 volts for you.
Did you
you're
read our
looking at a rack about 5 feet tall?
Did you read our materials?
I'm sorry, what?
Did you read our materials?
No, I didn't.
Was sent out. Okay.
No, I didn't.
I can do a screen share, Peter, if you like to, on those documents.
Let's not do that. I prefer that they are read, and then we'll discuss again, because we have different models. We have a models that goes for a house, 12 kilowatt system, 8 kilowatt system, a 4 kilowatt system, 1 kilowatt system. Then it goes up to 48, 96, and so on. This is how the system is built.
No issue. No problem.
Okay, excellent. So this is what I would like to know. So a smaller battery, let's say a 12 kilowatt battery, how much would that be?
How much would it cost?
How much would it cost?
You're probably in around the $12,000 mark.
12,000.
This battery
Okay.
right here, that I don't know if you can see it
No, I can't.
on the bench. This is a 15 kilowatt wall. That's about 12,500.
Okay, okay. What I'm getting at here, I'm doing this absolutely wrong now. I understand this because I'm comparing this with the batteries of lead acid, because for a 12 kilowatt system, I don't think we would need to have a 12 kilowatt battery. You would use a 6 kilowatt battery, right?
After you do your first prototype, you're going to get a baseline. Then you can judge off of that.
We need to put these two
All
together
right.
and start testing them immediately.
Then I would tell you to order 2 6s and have them in line with one of them off. And if you need more, you flip the switch.
Do you have 2 kilowatt versions?
Sure.
So we could put 2 plus 2 plus 2 plus 2, but because this is kind of how the generator works, it needs to have batteries in parallel. But I need to talk to Dr. Cho and see if you could use just one large unit for this. Then it would change a whole lot of things. Yeah, now this is becoming very interesting.
Well, you could put a DC to DC transformer on there and throttle it down if you wanted.
Well, we want to keep it in DC as long as the generator is driving the electrons through the batteries, because it will be turned into AC once it passes the inverter. And the inverter actually does the last ×3 of amplification, because it also has the same large condenser in it. So even if the generator breaks, the system will keep amplifying energy anyway. Not to the extent that the full system.
Well, you tell us what the specifications are, and we can build to you.
Okay, so you can put any amount of cells in the battery as per specification.
Yeah.
Wow. My dear friend, you are.
Well, you're familiar with Maxwell, right? With capacitors.
No, I somewhat, but not on the level that you expect.
Check this out.
Excuse me.
Guys, are you hearing this? He already
Can you see
5x
that?
the amount of energy. Yeah.
You see that, everybody?
Yep.
Okay.
Yes, sir.
Tesla bought Maxwell. Tesla paid $285 million for Maxwell because their brilliant engineers decided that their regen wasn't going to charge their lithium batteries, so they decided to buy Maxwell capacitors so that when you did the regen, took your foot off the gas and stepped on the brake, the charge would go into the caps. When you stepped on the go pedal, you wouldn't touch their lithium. That was their theory. Well, it doesn't work that way because the dry cell didn't talk to the lithium, so they just $85 million. So I just showed you 16 cells there. Those 16 cells are 2.7 volts each at 3,000 farads. This is mine. Exactly the same canister as that.
Yeah.
Theirs would take 33 units to equal one of mine. Okay? This is 100,000 farads. Yeah. 2.7 volts.
Yeah, I like how you put that comparison on the battery itself. That was funny.
I test against pretty much everybody's battery I get my hands on. So I know what the competition's doing, and like when I designed that wall battery, I designed it versus the Tesla Powerwall, and we took every one of their specs and we improved every one of their specs. So that was the game plan. So whatever you need, we're going to do our damnedest to make sure we get it for you. We'll do our best.
Yeah. Hey,
Mike,
Mike.
Where are you based?
I'm in Florida. I'm in Central Florida.
What is your company's name?
My company's name is called Zetech, Zetech.
Yep. Hey, Mike, I'm going to have Albert comment real quick before he gets in his meeting. Introduce himself, Peter, so you can hear this from a third party. Albert, can you share with Peter the testing that you did in the results?
Yeah, absolutely. Everything that the claims that are being made here with regards to the graphene battery, I could absolutely confirm. I've tested batteries for many years, lithium ion specifically, and not only myself, I had some of my peers with me from UL while we were testing this battery, and it's something that we've never seen with regards to the amount of energy that you could charge this at. We've never seen a smaller battery, cell phone size battery charge at this rate. A 4.2 volt cell. We were charging this cell upwards of 8 amps, and it was able to charge within about 10 minutes, and then discharging the same deal. And what's really amazing about these batteries is they don't produce any heat, or very little heat by comparison. I have a lot of charge curves on my drive that I'll make available. I've made available, and I see that there's been some requests for some more access to it, and I'll grant permission to everybody that's asked for it. And the testing, as far as I've done at this point, is still non-destructive. We are testing within the spec sheet as of right now, and we haven't really pushed the limits to find where these batteries are going to fail. But just to recap, this is something that I haven't seen before in my testing career with regards to these batteries. They're something else to it, and I'll be happy to share the data. I was told that I'll be getting some next. I think I'm only testing the first or second generation batteries at this point. I'm looking forward to the third and the fourth when they're available.
No, they're available. They're sitting over there. I just got back from the factory the other day, so I brought some.
Yeah, you and I were over there at the same time. Actually, I was right across the street in Taiwan while you were over there.
So are you on the wrong time zone too? I'm still on the wrong time zone.
I'm getting back right now. I'm starting to, I'm still up at 1 o'clock in the morning, and just it's still a little mixed up, but I'm used to it now. I go over there often enough.
Excellent. Hey, Albert, thank you so much for that. In your background, Albert, again, certification?
I'm an electrical and mechanical engineer, and right now I'm working in semiconductor. I work on capital equipment, a lot of logic controllers, PLC. Going through school, when I was going to college, that's when we were doing all the battery testing, and I'm still very much in contact with everybody in my previous positions. Like I said, sorry, I got a big truck going by. My previous role, I'm in contact with everybody. Like I said, I had Marty Hockman from UL in my lab for a couple of days while we were testing your battery, and he confirms that this is something that he's never seen as well with these batteries. So the battery technology is there. There's something to it, and I look forward to really diving into these tests. I want to see some of this destructive testing with it. I can't wait to just stab one of these batteries when it's fully charged, see what it does. And but they're
you better wear a rubber suit then.
Yeah, I mean, I have the box. We have a big glass box that we do this in, with basically an arbor press that we just fully charged battery that's even currently taking a charge, and it's all safe. I have all that equipment, and so we'll be doing this the right way, the safe way, and of course taking every data point we can. And
excellent. Excellent.
Yeah, thank you, Albert. Mike, I'm sure you can pop him one in the mail here, maybe tomorrow. We're excited about those results.
Yeah, sure.
Excellent. So next order of business, I'm going to hand the microphone over to Prajesh to introduce. Here we have.
Pop out. I'll look at the recording for what I missed on this. Just go ahead and put that up if you can, Ryan, and I'll get what I missed.
You got it. It's private. Okay.
Right.
So Prajesh, I'm going to have you introduce Mayur and Mike Patel. Again, Prajesh has been to Mike's shop. So Prajesh got some phenomenal connections, amazing businessman. So hello, Prajesh.
Hey, good morning, everybody. Thank you for the introduction, Ryan. All right, so Mike, hi, and everybody, hello. So anyway, Mike Patel is on the call over here. Mike Patel, let me introduce Mike. Mike, you want to give a quick introduction, your hotel experience, and Mike's muted. Anyway, let me talk about Mayur then. Mayur was on the call yesterday. those of you who don't know Mayur, Mayur is working with the Saudi government. In particular, one of the Saudi royals is Mayur's business partner, and they're working on the NEOM project, the Red Sea project, the line. So those 3 projects, Mayur is involved in them, on more of the construction and on agricultural side. So he has access to the big check writers.
Funds. Yeah.
Yes, he has access to those funds, and we feel that this technology, the battery, well, we start from the solar panels, the battery, and the amplifier all put together, right? That complete package would be amazing. It would just be phenomenal. I think just numbers, I think it's mind-boggling what you guys talking about. A battery which never, outlives you, and essentially we're looking at paying no electricity bill ever. Everything is put together on a residential property or even on commercial. I think that's all. So it's all amazing. I want to stick to the business side of the conversation today. What we need is, when are you going to Saudi? Exactly.
I'm leaving on 12th next week. I'll be there in Saudi Arabia.
Okay, so what my purpose is for, we need to put like a document together. So like a business plan, like a pitch deck,
Can I say something real quick? I'm sorry to bother you. On the technical side, where'd he go? Where'd the guy go? Is he still
here? Arian's here. Go ahead, Mike.
Peter. Yeah.
What are you using for solar over there? What's your solar panel?
No idea. I'm not from the energy sector.
We don't in energy sector.
Can I make a really good, strong suggestion for you?
Yes, go ahead.
I've got a solar panel that has no glass in it and is unbreakable.
Okay.
Hang on 1 second. Let me get a sample. Hang on.
Of course you do.
Black Sea. Yeah.
Tell us more.
We're learning more every day.
No, he's like all the trump cards. Let me just not bring them out now.
Right.
He's got 3 aces up his sleeve.
Jesus. Is Mike with us?
He's grabbing the phone.
Yeah,
Mike Patel.
Oh,
I am here. I'm on vacation, but I am
On working vacation.
trying to participate as much as possible.
Thank
Can you guys hear me?
Yes,
Yeah.
loud and clear.
Loud and clear.
Sorry, Mike, to drag you out of your vacation, but
I'm sorry. I apologize. I want you to see that solar panel. There's no glass in it. You can walk on it. Okay.
Wow.
And the reason I'm telling you that is, especially over there, when you get sandstorms and whatever, it's not going to pick. Okay. All you got to do is wash these things. This thing is going to last you 25 years, and it's without degradation. And it's got a good price, 450 watts.
Yep, that's what we'll need for the line, because it's going to be, most of it is glass, sort of a frame outside, and the buildings will be inside. So we have to create some sort of energy from that.
Okay, I'm sorry. I'm sorry. I apologize, but I wanted you to see that.
Is that
Yeah,
graphene,
sure,
Mike? Is that graphene?
No. It's a.
Well, that makes it cheaper.
It's got. Let me rephrase that. It's got a different composition, but it's not graphene. Okay, there is absolutely no glass in this whatsoever. Cannot break. You can walk on this.
Oh.
And the reason I did that, the reason that was developed was for the Bahamas, because they're in hurricane. They get hurricanes, and those, no matter what you put there, they get ripped up. This thing won't get ripped up.
What's the thickness on that?
Yeah.
Thickness?
Well, you mean of the frame itself, or the or the panel?
Panel.
About 1/8 of an inch.
Okay.
What?
Can you show that panel again? Did you say that thing was 250 watts?
450.
No, 400.
Wait.
That little one.
This is just a sample. The full size one's 450.
Ah, okay.
This is just a sample.
All right, fine.
Yeah.
Fine.
What I did was,
thank you.
what I did was I took my little battery here, and I've got. I'm sorry, I got all kinds of stuff around me. I've got a 500 watt, a 700 watt inverter with my little battery, and I was using this to charge that battery to make sure everything was going to work, because I had that panel, okay, and this has got no glass in it either, but this is kind of one of those foldable ones. They're not really rigid enough, so we designed this one to take its place.
Awesome. Hey, Mike Patel here has a question on vacation.
Yeah, so I've got 47 acres of land in Fort Myers, Florida. I'm struggling on a development that I was intending to build 500 unit apartment. But I'm having issues because of the soil composition, and some environmental issues, right? But I was thinking, because this was brought up in one of my development meetings, is using that site for solar panel, right? To work some sort of deal with the city on a conservative level. Is that something you think that putting with that much land availability, what can we do with this technology and how would we sell it? Whether it is being
one of the things that you want to do with that
energy.
is with the batteries as storage is have your storage for peak power, because as everybody understands, the grid is not designed for what they want to try and use it for. So yeah, they would probably kiss you on the lips.
Yeah.
Make sure
Also
she's
another
back.
thing. Also another thing on 47 acres with the combination of that battery and the amplifier, we can probably power a very large part of the state.
Really, on 47 acres?
Yeah.
Yeah, because we amplify the energy 10 times, so I'm fairly certain that the lines to transport all of that energy out of there, they wouldn't be sufficient enough. We would melt the lines.
Where are you located in Florida?
We're in Fort Myers, Florida.
Where are you located?
In Fort Myers.
You're in Fort Myers too?
Yeah.
How about you set up a little meeting so I can come see you eyeball to eyeball? I think I can show you some stuff that's going to make you real happy.
Okay. I mean, we own the land, so, and we're trying to figure out, so we're scrapping our project on building a multi-family community there.
Mhm.
But I'm looking for things that are going to be a little bit more environmentally friendly and stuff. So I think this would work great. We need to, so what I'm proffering to you guys is the 47 acres is available. Let's figure out how to move this along.
I can show you. I got a whole plan for you already. We've got solar street lights. We've got golf carts that actually you can, with the hybrid inverters, you can use the golf carts to charge the house as well as your EV cars. Got a whole plan for you.
All right.
Awesome. Man, usually people come to you, Mike. This is unheard of.
Well, the missing ingredients is funding. Okay. If the funding's there, the sky's the limit.
Hey, Mayor, let's talk about funding. Yeah. You want to comment on that?
Yeah. We got funding from the PIF, that's public investment funding in Saudi Arabia. They've got allocation of between 600 to 800 billion dollars for building up the new smart city and all that. So every development in that area has to be very smart with EPA control, and you know what I mean. So that's what they want, and we involved in a project for 10,000 houses to be built, plus additional 7,500 homes. So we're working on that project right now, and we also involved in defense projects in Saudi Arabia as well.
Have you got any discretionary funding that you can get your hands on? So
yeah, I can work, but I'm going to present these things to the
samples?
PIF. Yeah. We have connections at PIF, yeah.
Okay.
So I got to present the business plan and all that to them and then work from there.
Okay.
But we have the access of getting things done there.
Okay.
Yeah.
Hey, Mike, would it make sense to make a manufacturing facility with these two technologies combined right in Saudi Arabia?
Absolutely. I mean, their technological prowess over in that area is pretty much second to none. The thing of it is what I would suggest that they do over there is do an assembly plant on site. Then they can hire local workers. I mean, the government's going to like them a whole lot better that way. Okay.
That's right.
I wouldn't necessarily get involved with the manufacturing because that's going to take a while to happen over there, but definitely the assembly portion of it. And for the kind of volume that you're looking at, we're going to need additional assembly plants. That's why I asked how the funding was going. But one of the things I would strongly suggest is if they get their hands on some discretionary funding, is ordering some sample units of a megawatt, our big unit, so that when people actually see it and see the quality, and you're not talking on paper anymore, you're actually seeing it in front of you, it's pretty much a done deal.
Mike,
That's right.
how much funding are you looking for, Mike, for something like this?
I'd say if you can get your hands on 15 to 20 million dollars, you'd be okay.
Mm-hmm.
How
Okay.
much product can you put out from that amount of money?
Well, you'd get an ESO unit and you'd get an ESS unit. So you'd have 6 megawatts worth of storage along with the electronics. That's gonna get you going. But again, that's everything you do. Not one bit of it's going to be wasted because you can use it on your project. And not only can you use it on your project, you can use it in your testing facility to do your prototyping to make sure everything's going to work out in the field.
So for each 20 million, we can get 6 megawatts of battery pushed out per year.
No, that's just the sample. That's the start. That's the start. We can build up to 10 at a time.
10 what? 10 factories or 10?
10 of the ESS units, the 2 megawatt units.
So 20 megawatt.
We have 2 different units. We have what's called an ESS, energy storage system. That's what you're going to tie your solar into. That has the electronics in it, along with 2 megawatt hours worth of super caps. Then we have an ESO unit that has 4 megawatts hours worth of pure storage that plugs into the 2 megawatts. So you put a couple of megawatts worth of solar out there, you're running 6 megawatts worth of storage.
So what I was asking, the factory, the plant itself, the assembly plant, how much would that cost and how much product would it push out?
I would tell you that if I were to tell you how to do it, I would put the robotic plant in. Right now the plant is heavily, it's manual labor. You're looking at about 500 modules per month. Come September, October, when the equipment arrives, you're looking at tens of thousands of modules per month, and every one of them will be perfect. So, I mean, that's what I would strongly suggest that you do in Saudi Arabia. And as far as pricing,
what does it cost?
I can't give you a real price right now because I don't know the real price. But I can tell you this: I would trade dollars with you on equipment because we'll make it up on volume.
Got it. Yep.
But I can send you the cut sheet. You'll see the assembly line. You'll see everything, how it functions. I'll send it to Sunny today so she can forward it on to you guys.
Okay, that's great.
But that's the direction you really want to go. I have a factory in India, in Ludhiana, India, that we can access. I've got our factory in Turkey that you'd be accessing. So, you know, it's all on your side of the world.
Yeah, because I'm going to Turkey on 16th. I'm flying to Istanbul on 16th.
That's where our factory is, right in Istanbul.
Okay, all right, okay.
Hey, Mike, Mike Dana, this question. Mike Patel is in Florida, Mayur is in Florida, you're in Florida, and I'm in Florida. Maybe we should do a lunch in somewhere, maybe Orlando, or I don't know, Tampa, maybe. So it's easy for everybody to get to.
Wherever you say, man. I mean,
right?
this is a big deal. I'll go wherever you want. You tell me.
What part of Florida are you in?
I'm in Central Florida. I'm an hour north of Orlando. I'm in a town called Leesburg.
Okay, that's not far from us. We are in Orlando.
Yep.
Well, if you're in Orlando, come
Can
down to my
I
shop.
suggest that we
and you can see
meet
the
up
stuff actually
over in
working.
Tampa?
Yeah. So we should do this before Mayur leaves. Mike, when do you get back from vacation?
I'm here.
Saturday.
Saturday. Okay, so Monday, Tuesday. Mayur, you live on Wednesday, right?
Yeah, Wednesday.
Yeah. So we have Monday or Tuesday next week. We definitely should meet. And do we think we have enough time to put the deck together for everything which is battery and everything which is amplifier related? Like put a whole pitch deck together. And
well, I can do the battery side. I've got Sonny Nicole on my side, so you know they can do my battery.
Yeah, and the fact that you just told us that you 5x the current with the current setup you have, that gives me a pretty good idea. So I can already include the battery with the generator. So I'll just do an assumption that we would 5x the already 10x energy. So I'll put something together regarding that, but it's theoretical, but I will of course explain the what we know about the generator from the past 10 years of manufacturing and use of it.
All right. So my understanding is, Mary, when you go to Saudi, you'll probably, give the deck to somebody in one of the business managers.
Authority, yeah.
So one of the business managers. Now, we would definitely need to do a call when you're there, and we would look. So basically, we need one person. We don't need to have the whole team on the call, but we need obviously we need Peter and Mike on the call, and then we need to have one spokesperson, or maybe we can have both of you and we can talk about it. So
I have somebody in Saudi we can arrange. He can be on the middle of the call as well.
Right. So, Mike, can you find?
He's sort of working for us for the hydrogen stuff in Saudi Arabia right now as we're talking.
Is he well versed with electronics? Do you think he'll?
Yeah, he is. Yeah.
Okay, fine.
And then they'll get the head of the engineering for the NEOM as well.
Oh, you do have access to that guy.
Yeah.
Okay, fine.
Yeah, so we'll get two guys on the phone call as well from
So
NEOM.
we want to do. So the idea is, again, we talk to them. We give them all the paperwork. Maybe we can print 3, 4, 5 copies of the whole thing. Put a nice binder together. You present, and then we organize a call, and we give everybody enough heads up. We can do just like this, a 1-2 hour call. We can talk about. We can start with the solar panels and work our way to the batteries. And we can explain to them. So the whole idea of this call is basically Mayur and Mike Patel can understand what I'm doing with Mayur on the batteries, and he gets a little bit of idea of what the technology is, and then to discuss the next steps, because we can talk. Look, the technology is amazing. I'm not a technology guy, but just listening to both of you guys talk and getting, just salivating over all the numbers. I believe the numbers are amazing. So we just have to figure out how we're going to put this to reality. How are we going to get the factory up and running? That's the main thing.
Yeah, and I just had a call with somebody on Jizan. We are involved in a company. We do fishing and all that. They do 70,000 tons a day catching fish in Red Sea and all that. And they just put up 500,000 square foot of warehouse there with the cold storages and all that. So we were just talking about putting solar there as well.
There you go.
Yeah.
We have.
I mean, they will need it.
An hour ago, we just having a call on that. So we on the starting age on that as well. So I'll send you some information on the plant and all that as well.
Okay.
So that could be a great starting point to get Mike's solar panels.
Some sort of pilot project or something. Yeah.
Right. Now, I think everybody has this technology, but as it stands, we don't have the mass manufacturing capacity for anything. Is that an accurate statement?
Yes, correct. We can be up and running in 6 months.
What, Mike? Dana?
I've got capacity. We can handle it.
Okay, Mike, Dana. So that's obviously out of China, correct?
I'm sorry, say that again.
Will that be out of China or Istanbul or India?
He's got it in India, right?
It would be all 3 factories. We'd put all 3 factories to the task.
Okay. All right. So Mary, we have 3 factories: Istanbul, India, and China. So solar panels is not an issue, and graphene batteries.
How are we going to incorporate Peter on his technology and all that as well?
Well, I would be he would be the main drive.
Right.
I would only be the storage.
Okay, all right.
Okay, I'm like the fuel tank.
Okay, good enough. That's fine.
Right.
Any more questions?
Great call.
Okay.
Where's
Anybody?
Peter?
Peter's left.
You guys, if you guys want to meet someplace for lunch or whatever, let me know and I'll be there.
Or we'll try to arrange on Monday or Tuesday next week.
Hey guys, do you mind if Scott Lane comes down also? He'd love to meet you all too, and he's got a lot of experience too. Is that okay with you?
Yeah, sure. Go ahead.
Yeah, he can buy lunch.
Yeah. That's a good one.
Scott, where are you based out of?
Chico, California.
Oh, that's too far out.
No, yeah. Well,
we're his own plane.
So we lost him.
Let's confirm it. Let's confirm a meeting time then. When's that meeting going to be?
Should we do Monday lunch?
Yeah, why don't you guys just put it together and then text me where and when, and I'll be there.
Okay.
Okay, Monday.
Right.
Scott, that good for you, bud?
Yeah, I can make
Mike,
it.
Mike, where do you suggest, in
Sunday.
Tampa or in Orlando?
Tampa. Mike suggested Tampa.
Okay.
You know what? If you want, Mike, we can do so. We can have a meeting in our office, in my office.
It's up to Mike. I don't know.
You talking to me?
No,
anywhere.
Mike Patel.
Oh, anywhere.
Because if you're doing
I
the
might
restaurant,
have to move. I may have to move the meeting to Tuesday, guys. If you don't mind, I might
Okay,
have to
sure.
go to a funeral on Monday. We're just trying to pinpoint the exact date for this funeral, but then I can leave from West Palm and meet you guys up there in Orlando.
right, let's do it on Tuesday. Tuesday sounds good to everybody. We can meet on Tuesday lunchtime. Say 1 o'clock in my office, and I'll text everybody the address. Oh, well, I'll pick a restaurant nearby, and we can just go there lunch, and then we can come back to the office and spend another 2-3 hours and have a really cool understanding. And I'm pretty sure Mike's gonna be excited to bring some samples over and demonstrate how amazing the technology is. I might get one more person to join, right? Maybe 1 or 2 more people, one of my friends, to join over here, and see. So we'll organize a whole big party.
Sounds good. I'm good. I'm in.
Where would we fly into?
Sorry, what was the question?
Where would I fly into? Is it in Tampa or Orlando?
Orlando.
Excellent.
All right, Ryan, maybe what you can do, set up a group text. And I'll add Mayur and Mike to the group text. I don't know if you have Mike's or Mayur's number, but I'll add them to the group text. You add Scott and Mike Dana as well. Okay. So start that, and then we'll just add, and so we'll have the whole group, so we'll coordinate everything.
Peter, try to get some sleep tonight, okay?
Yeah.
Well,
Peter and Mike, especially.
You too,
I'm
Mike.
going to think about how much energy we're going to make.
Right.
Yeah, that was the missing part. As I said, I've been with a group that had a graphene battery, but they never got it to the shop shelf. So now we found it.
Peter, I'm just curious, when did your business partner pass?
A year and a half ago.
Oh,
Yeah.
sorry to hear that.
Yeah, that was very unfortunate. He was a brilliant man. He was actually a gentleman that took Nokia Corporation to be the world leading mobile company back in the day. And what he did, he did something fantastic with the battery. He adjusted the battery current, and then the 3810 model came out, which is still one of the most sold mobile phones in the world.
Mm-hmm.
Yeah. So he was a brilliant inventor. That was a huge loss, but well, now we have a new guy.
Mm-hmm.
The world keeps on moving.
Yep.
Okay, guys. Thank you.
Forward.
You're welcome.
All right, thanks everybody.
All right.
Thanks for the call. Yep. Thanks.
Thank you.
Okay.
Take care.
Thanks.
Bye-bye.